Last episode the pipeline worked. About 60 lines, 3 functions, the right answer with a citation. Then we slowed down on the top 3 retrieved chunks and noticed something off. Position 3 was a meeting note that just happened to mention the word cancellation. Cosine Similarity ranked it at 0.80. That's the same score range as the actual catalog page. Relevance is not the same as similarity. This episode we fix it. Vector search is a Bi-encoder. The query becomes one vector. Each chunk becomes one vector. We compare them. The score is high when the meanings are similar. But similar isn't the same as useful. A meeting note about a cancelled off site and the actual cancellation policy live in nearly the same neighborhood of the embedding space. Cosine cannot tell them apart. Cosine wasn't asked to. A reranker is a different shape of model. The Bi-encoder embeds the query and the chunk separately. They never meet until the dot product. A cross-encoder reads the query and the chunk together in a single forward pass. Same words on the same attention heads. The output is one number, relevance, trained to rank passages that actually answer queries higher than ones that just sound related. Cross-encoders are slower because you can't pre-compute. They're more accurate because they actually look at the query and the chunk in the same context. Same pipeline. Add the Reranker after search, 4 lines. We load a cross-encoder model once at module load. The EMS Marco Minilem 90 MB runs on CPU. Take the top K from vector search, say 20 candidates. Ask the Reranker to score each query chunk pair. Re-sort by the new score. Keep the top 3 for the prompt. The vector search is still the funnel. The Reranker is the filter. Watch the top 5 reorder. Before reranking, SKU1042 description first, cancellation paragraph second, meeting note third. Cosine ranked them all in the 0.77 to 0.8 range. After reranking, cancellation paragraph jumps to first because it actually answers the question. The meeting note drops out of the top 5 entirely. A different cancellation chunk that was sitting at rank 7 climbs into position 3. Same retrieval, different verdict. Plot what cosine and the cross-encoder say about the same 20 chunks. Cosine put all of them in the same narrow band. From its point of view, every one of these chunks looks similar to the query. The cross-encoder spread them out. A few got high relevance scores, most got negative ones. The meeting note from EP02 sits at the bottom of this column. High cosine, negative relevance. Cosine couldn't tell it apart from the right answer. The cross-encoder told us exactly what was wrong. We feed the new top 3 into the same prompt as last episode, same Gemini Flash, same template. The answer is still about cancellation terms, but now the model has the right paragraph at the top of its context, not the SKU description. Precision at 3 goes from 2 out of 3 to 3 out of 3. 1 config change, no retraining. And this is how you reduce hallucinations in retrieval systems. Not by changing the model, but by giving it better evidence. There's no free lunch. Bi-encoder search ran in under 500 milliseconds. The cross-encoder takes longer. The first call has to load the model, but after that, scoring 20 pairs runs in about a second on CPU and tens of milliseconds on a GPU, depending on setup. That's the trade-off. You retrieve cheaply across millions, then you rerank a small set. You don't rerank a million chunks, you rerank 20. This works for our query. It works for most queries against this corpus. But here is the next failure mode. What happens when the right answer is split across 2 chunks because the splitter cut a sentence in half? The reranker sees both halves as half relevant. It can reorder them, but it cannot stitch them back together. Next episode, chunking benchmarks. Same query, same reranker, 5 different chunking strategies, 2 winners, 3 losers, EP4.